Hi, my name's Sue Glenn. We're going to be talking about the age distribution of populations. This is from Chapter 10 in Ecology, Concepts and Applications, 8th edition, which is Manuel, Molles and Anna Sher's book that was published by McGraw-Hill in 2019. Look, those are some cute Galapagos finches that Darwin saw. So age distribution of a population reflects the history of the survival of individuals, and we've been talking about survivorship already, the history of reproduction, so when reproduction occurred in a population, and was there a baby boom at some point, and the potential for future growth of the population. So you can tell a lot by looking at the age distribution, and they can indicate periods where we had lots of reproduction, periods where we had high survivorship, low survivorship, whether or not there's enough young to replace the old. And so we've been using these for a long time, and this is a lot of the information you get out of the census is looking at the age distribution of a population so that you can plan for the future. So the first example in the textbook was some work by Robert Miller in 1923, and it's looking at the age distributions of Quercus Alba, which is white oak. And so he took time and he measured the sizes of 56 trees of various sizes. And then he took a corer to get a little sample out of the trunk so he could actually count the rings. So he could figure out just by measuring the size of the trunk how tree was. So he had determined a relationship between the age and the trunk diameter, because clearly the bigger trunks were going to be older trees in general. It's not perfect, but it does give you an estimate. The age distribution is a little bit biased towards young trees when he looked at that, which meant that is not a bad thing, this bias. It means that the forest had a lot of young trees. It had a lot of smaller trees, which had fewer rings. It had a lot of young trees, which means when the older trees would die, there was lots of young ones to replace. So this is what the age distribution looked like, that you have the age across the x-axis. So we had trees up to over 300 years old in this data set, and the percentage of trees in each category. So this is a frequency distribution. So most of the trees were under 50 years old, which shows that the population is dominated by young individuals, and there's sufficient reproduction to replace the older individuals. The next example is looking at the age distribution of a population of Rio Grande Cottonwoods, which is a subspecies of Populus deltoides, which is a common tree species. The Rio Grande River runs through central New Mexico and Texas. It's the border between Mexico and the U.S. And the most extensive cottonwoods forests remaining are in the middle range of that in central New Mexico. And so we can see in this particular photograph the yellow treetops. That's a fall picture of the cottonwood trees with the yellow tops on them. Here's a big old cottonwood in the wintertime, big gnarled trunk. So you find these growing on the edge of the river, and we do find that their populations are declining. So they are disappearing as these big old ones are dying, and the old trees are not being replaced in the population. It turns out that the reproduction of the Rio Grande Cottonwood depends on seasonal floods. This is a little sign that was found in Roma, Texas, of a painting that somebody did, a little bit of folk art, showing them the big flood they had in July 2010 right along the Rio Grande. And what these seasonal floods would do is provide an area of moisture and silt. It's a very dry region, and it adds a nice place for the seeds to germinate from these cottonwoods. And the seasonal floods have been becoming less and less common because what they have done is they have put all sorts of dams along the Rio Grande. This is a huge one where they've made a giant lake behind it. And they're trying to control the flooding so that houses along the Rio Grande and places along the Rio Grande are safer. But what it means is you don't get this flooding and the overspilling of the banks, and these seed beds are absent now, and the trees cannot germinate. At some point, they're going to build too close to these rivers, and these dams at some point will overflow and flood and cause all sorts of havoc. What they are really building along these edges of these rivers are the wall between US and Mexico, and that wall, when it gets hit by these floods, is going to break, and then that'll have huge pieces of debris going downstream that's going to threaten those people. It's going to be much worse. So if we look at the age structure of this population, it looks very different than the graph we saw of the age structure of the white oak. If we look at the age, these guys don't live as long. They can live up to 70 years, but most of them are 40 to 50 years old. But we see there's no young trees. There's hardly any young trees. The percentage of young trees in the population is 0. So we really are not getting the replacement and the germination of this population. So we're expecting that because of this flood control, these trees are going to disappear, and there's going to be no young ones to replace them. Next example, looking at age distributions that we're going to talk about, is some work done by Rosemary and Peter Grant. They're a couple who spent decades in the Galapagos Islands studying Darwin's finch populations. And one of their most thorough studies was the large cactus finch, Geospiza conerostris, which is in the northeast portion of the Galapagos archipelago. The Galapagos, as you know, is in the South Pacific. It's 1,000 kilometers off the west coast of South America, and it does have a highly variable climate. You can get El Niños, you can get years where you have lots of rainfall and years where you don't have very much rainfall. So we have a variable climate here. And in 1977, a drought resulted in none of the young finches surviving that year because the parents couldn't get enough food for them. So this is a cactus finch. It nests up in the cacti, and this is the data from 1983, and they look at the age distributions as we've been talking about, and as you can see, there's a gap. There were no 6-year-old finches. So in 1983, 6-year-old finches would have been born in 1977, and so because of that drought, none of them survived. And so up until that point, it was fairly even, and then 1977, there's no baby finches surviving, so that in 1983, you see no 6-year-old finches. So you look at an age distribution, and you can see when was a year where reproduction was poor. There were additional droughts in 1984 and 1985. So when we look at the data again in 1987, like these, Rosemary and Peter Grant were out there every year collecting this data, and they could see that in 1987 there were no 2-year-old finches, so there were none that had been born in 1985 that survived, and none that were born in 1984 that survived. There were no 3-year-old finches, but we can see there was a really exceptional year in 1983 where there were like a ton of 4-year-old birds because they had really wet weather that year. So that was a very high production of food that the finches depended on for reproduction. We can also see there was no 10-year-old finches. Remember 1977, that was that drought we just talked about. So this was 1987, 10 years later, there's no finches in that age group. So this is showing you the responsiveness of looking at the population age structure to variation in the environment and get a lot of information out of this. I also highly recommend taking a look at this YouTube video. It's a paper presentation by Rosemary and Peter Grant, and it goes over a lot of the research that they did. Not only this research, but other research that we'll be talking about in later chapters. So we've seen that age distributions give us a lot of information about how a population is changing, whether it's growing, whether it's declining, whether it's stable. And then the next section of the textbook, we're going to talk about population change. At the end of this section, you should be able to answer the 2 concept review questions. The first one, can a healthy population that's not in danger of extinction have an age structure that shows years of reproductive failure? And the second one, the last major natural reproduction by Rio Grande Cottonwoods which produced a large number of 40 to 50-year-old trees, is documented by Howe and Knopf in 1991 and occurred before the last major dam was built on the river. Is there any evidence for reproductive failure before that dam was built? So look back at that figure of the cottonwoods and see what you come up with. And we will see you then to talk about how we calculate rates of population change.